that you're familiar with Euler's method, we are just going to compare the answer that you get from Euler's method and the particular solution. At the end of this lesson, you'll be able to compare Euler's method approximation to the particular solution of a differential equation. Please keep in mind that you aren't able to always find that particular solution, but when you are, I just would like you to get a good idea of really what it looks like when we're finding it, so you have a better understanding of Euler's method. Okay, I'm going to be taking example 2 that we did in the previous video. If you recall, it was dy dx is equal to 2y and then x plus 1. The initial condition was y of 0 is equal to 3. And then I'm also just going to write down the approximations that we did end up with. We had 0, 3, 2, 4.2, 0.4, that was 0.4, 0.2, 0.4, 6.216, and 0.6. 9.697. So again, what I'd like to do is just compare the answers that we got to the actual particular solution so you can see how it actually does work. All right, so first thing we're going to do, if I ask you to solve this differential equation from Calc AB, what we would first of all do is put a 1 underneath here and cross multiply. So I'm going to get 1 dy is equal to 2y times the quantity x plus 1 dx. We do need to get our y's and our x's together, so I'm going to divide both sides by y. So I'm going to end up getting dy over y is equal to 2 times the quantity x plus 1 dx. I do have my variables separated now, so I can go ahead and take the integral of both sides. The integral of dy over y is the natural log of y. And then the integral of the right side, I think I'm actually going to distribute the 2 first, so I'm going to get 2x plus 2. And then since there's a plus sign, we can treat each part separately. So the integral of 2x will be x squared, and then get integral of 2 will be 2x. And then, of course, we have to add our plus c. To get rid of the ln, we will do the logarithm loop, if you recall that. So I'm going to get e to the x squared plus 2x plus c is equal to y, and if you remember from previously working these problems, we get to put the c out front. So I'm going to have y equals ce to the x squared plus 2x, and then from here we do need to find a particular solution. When x is equal to 0, the y is 3, so I'm going to have 3 is equal to ce to the 0 squared plus 2 times 0. That's going to give me that c is equal to 3. So my particular solution would be y equals 3 e to the x squared plus 2x. So again, what we would like to do is compare the table that we got to the equation that we got, and I just want to show you that the points actually are approximating the actual solution. So go ahead and get your calculator at this point in time, and I will get mine too here. Alright, so I have my calculator now. I noticed that first of all I just typed in, I went into the graph screen and I typed in 3e to the x squared plus 2x. So if you need to pause for a second and type yours in as well, that's fine. And now what I'm going to do, I actually need to enter my points. So the way that I'm going to do that is go to Stat, and then we'll go to Edit. If you already have things in as L1 and L2, remember we'll have to clear those, so just go up to L1, press Clear, Enter, and that will clear that list. And then again, go over to L2, clear, enter. At no point in time do you want to press delete, because it will get rid of your L1 and your L2. All right, so now I'm just going to enter the 4 points that I found. I had 0, I'm going to do my x's first, 0, 0.2, 0.4, and 0.6. And then let me enter my y values. My y values were 4.2, and then 6.216, and then 9. Oopsie, guess what I did? Didn't enter my 0, so it should be 0, 3. Here we go. 4.2, 6.216, and 9.697. All right, so we've got the points in there. Before we graph it, I am going to, well, actually, I'm going to do a scatter plot. So we'll do second stat plot. We want to make sure our plot, right now our plot's off. We would like to turn it on. So if you just press enter, it is now on. We need to, press enter. There we go. Now the on is clicking. Notice I'm fine because this shows me right here that I'm in the scatter plot mode, so that's exactly what I want, so we're good to go. The next thing that I'm going to do before I actually graph it is change my window. I'm going to actually zoom, and I would like to zoom it according to my data because I want all the data points that I picked to show up. So actually we're going to do zoom stat. So if I do that, you will notice you will notice that this was the actual solution curve. These were the points that I had actually found. So you'll notice it's forming the general shape. I'm guessing if I would have made my step size a little bit smaller, I probably could have gotten a more accurate solution, but that it gives you at least an idea that we are starting to get that trend of the curve. So that's what we're finding when we use Euler's method.